Hi guys, in this video I want to show you some control structures in C, an example for using an if statement and loops like for loops, while loops and do while loops. For having a nice example in a demo, I will use program arguments. You use program arguments all the time. For example, when you compile your C program with GCC, then you type in GCC, maybe followed by some options, followed by the name of the source file. And then this additional options and this name of the source file are arguments that you pass to this program. So it has to be possible that programs access these arguments. And in C, that's easy accessible. Function main actually gets information about these arguments. So far, we didn't care about that. That's why we declared the parameter list as empty in function main. Now we do care about it, so we will declare the function differently. In the demo, I will use two parameters. In the exercises, you will see that actually a third parameter can be used for accessing environment variables, or the shell variables that are exported also can be accessed from within function main. Now here in this declaration, you see the first parameter is an integer. And the meaning of this first parameter is it's the number of arguments. Here you have to know that in C, the name of the program counts as one argument. That means argc is always at least one. And this second parameter has type pointer to character. It's actually an array with pointers to character. So you also could declare it like that, which is a bit more expressive. But recall that an array is just a pointer to the first element. Now, the meaning of this second parameter is that, let's say this program gets called with two additional arguments, then argc would be 3. That this first element of argv would be a pointer to the name of the program, which is a string, of course, 0 terminated, and the next element would be actually pointed to the first argument, and the third and last argument would be pointed to the last argument. So if we exactly know the number of arguments, then we could print out the name of the program and its arguments with this code. But of course, this is not very flexible. If a user would provide more or fewer arguments, we would see some strange output, or we would not see all arguments. So this calls for loops, of course, or if statements. And so this is what I use in the demo. I will start here from scratch so that you in parallel also can type in this program. So I will include standard IO, so not like on the slides directly declare this function printf, but I will mention this here in the comment. So in the beginning, I think it's kind of a good idea to know why am I including certain things. So this function printf gets at least one parameter of type const char asterisk. So this is a pointer to a character, and we should not modify what's at the end of this pointer. And then we have an optional list of further parameters. And then in function main, we have two arguments, two parameters. The first has type integer or type int, and this is called argc. And then the next is an array with pointers to characters. And then we use a printf statement to print these arguments. And here I actually could make it a bit nicer. I will use a placeholder here for the index, and then I want to print a string. So this index is first 0, and this string is what is at the end of this pointer stored in the first element of argv. So we have this here. Now I need this 2 more times. Then I replace here just the 0 with 1. And here I replace the 0 with 2. Okay, that's it. Now I will compile it also with all warnings shown in case we have any, and the executable should be called args, and the source file is called args.c. Now I call it with no additional parameter. That means argc is 1, and then you see it's actually still printing something. So this first argument, or this argument with index 1, is obviously a null pointer. And here this actually points to some string. So kind of nice to see what you can find in memory. And yeah, of course, we also should use additional arguments and test all these things. So of course, if we exactly have in total 3 arguments, including the executable name, the program is working perfectly fine. Here we don't see all arguments, and otherwise we just see whatever these elements have for initial values. So now, of course, we should make this a bit more flexible so that we exactly see arguments that the program receives. And for that, I will begin with the do while loop, which is actually a loop that you, at least for most things, don't need that often. And some programming languages don't provide it at all. So the idea of the do while loop is that you execute the loop body at least once, and then you check whether a certain condition is met. And if that's the case, you loop back, you do the loop body again. So what is the loop body? First of all, this keyword here indicates that we have this do while statement. Then the loop body is, in this case, this compound statement. You will see in the grammar that actually just one statement has to come after this keyword do. And if we just have a single printf, we would not need a compound statement, this curly braces. But that's my coding style, that I'm always using compound statements even if it's not required. Now the idea is that this loop body, that means in this case whatever is in this within this curly parenthesis, gets at least executed once. Then in this after this while keyword in this parenthesis, I can use a condition, an expression, and if this expression evaluates to something different from 0, it's considered to be true, then it loops back. It will execute this again. And otherwise, you continue with whatever statement comes next. So here, first of all, I need some way to check whether I should continue or how many times I printed an argument. And I will use for that a counter of type int, local variable, so I have to initialize it. And then I also change this here from 0 to I. So the first time I will print the argument with index 0, so the program name. Then I increment this counter, and then I check if the counter is still smaller than argc. Then I have to print more arguments. And on the website you will find flowcharts describing the meaning of this loops. But I think here it's kind of natural to read it like English text and kind of obvious what it means. Okay, so now recompile it again, call it with one argument, a few more, then you see it works. Let me also show you a way to save lines of code. Not saying that you should do it, but it would work. Of course, I also could increment the counter in here. I mean, once this condition is checked, we either have to redo the loop again with the incremented counter, or we don't need the counter actually in this program anymore. And this would do the same trick. And then you can show off that you know about precedence of operators in C and that you can save one line of code. Okay, no big deal. Now the next loop will be a while loop. And a while loop has, in compared to the do while loop, the while loop will first check the condition. So I also have here in parentheses some condition, which again will be whether the counter is smaller than argc. So as before. And then I execute the loop body, and then I check again whether the condition is true or not. So we first check the condition. If it's false the first time, the loop body not gets executed at all. Otherwise, it gets executed once. Then we go back, check the condition again, and so on. So would do the same thing if I do not forget to increment here the counter. And that's it. Okay. Obviously doing the same thing. Now you see one disadvantage of this while loop is that in the end of the loop, you should not forget to increment this counter. And also, we should not forget to initialize this counter before we enter the loop. And for this, the for loop is perfect because this for loop provides both. It provides an initializer, and since C99, you also can declare a variable in the initializer. So here I'm declaring or also defining the counter initialized to 0. Then comes the condition, under which condition should the loop body be executed. And then in the same line, I can express what should be done after the loop body was executed. Each time it should increment this counter. And this is kind of nice to have in one line, this precondition, this condition to do the loop body at all, to execute the loop body at all, and this post condition that afterwards always the counter gets incremented by 1. And of course, doing the same thing. Now to bring here some if statements into the game, I will change the program so that like in GCC, I distinguish between option arguments and non-option arguments. So if an argument begins with a dash, then I want to print out this is an option, and otherwise this is no option. And with that, I also can reconnect with this topic pointers and arrays. So I will check here before I print something if this first character of the string is a dash. So if argv points to a dash, it means at the end of this pointer, that means I need here an asterisk, I will find something which equals to the character dash. And then I will print here option. And otherwise, I will print no option. And then I can use an if then else statement. Actually, you don't see an then here, but I still call it like that because the meaning is if the condition is true, then this block of statements will be executed, and otherwise, if it's not true, the else branch. And you actually do not need to always use an else branch. It's optional. You see this also in the description on the website. But here it's nice to see both. Actually, I want to clear here. Okay, that's it. Actually, in this case, we could use, instead of this if statement, a conditional expression, and we would save a few lines. Let me show you that. So first just copy here this here. And I want to replace here this string with either option or no option, depending on whether this first character is a dash or not. So I will first of all use a placeholder for string here. And then here before this parameter I will use a different parameter, and this will be evaluated with this conditional expression. And the condition for that will be that the pointer points to a character, the dash symbol. What pointer? The pointer which I have in the array with index I. So if this equals to the dash symbol, dash character, then I want to have the string option, and otherwise the string no option. And that's it. So with this single statement, I basically have the same effect like here. Now let's check this out. Yeah, behaves the same way. I'm not saying that this is better than before. I just want to use this opportunity to show you that you can do it. Okay, but let's change this here back. And then I will show you another example where I'm actually comparing completely to strings. It means all characters of the strings, not just the first character. And for that I will use a function from the standard library. It's declared in the header string.h. And the function I use has a return type of int. The function is called string compare, written like that, and receives 2 pointers to a string. So in both cases we have a const pointer to a character. That means what is at the end of the pointer should not be changed. Let's call this s1 for string 1, and the next is called s2. Now the reason why you get here an int as return type and not just a bool for is the same or not is that you can use it to order strings. If s1 comes after s2, if you order them alphabetically, you get something positive as return value. If it comes before s2, something negative, and if the strings are equal, then you get 0. Now I want to change the program so that if one parameter, one argument is exactly the string foo, it prints here instead of no option, this is foo, colon, and then the argument, and otherwise just this string here. So for that I will use a if statement again, and I will have this here twice. In this first version with this additional this is foo, and this only should be called if this string in this argument is equal to foo. So I'm comparing arg v index I with the string literal foo, and if this returns 0, this string is printed, and otherwise this string. Okay, then we check that out again. Okay, works. Now in this form you rarely will see a string comparison by C programmers. They will usually write this with this logical not, because of course 0 means false, anything else true, And that's how people use it. But you should understand the meaning that not means actually it's the same. And also check that out. Okay, that's it for this demo. On the website, you of course will find grammars describing all these statements that I showed you in the demo, but also flowcharts describing the meaning, the preciser meaning of these statements. And with these flowcharts, you also have a way to translate C code into assembly code, or I can provide you in assignment C code as pseudocode, and together with these flowcharts, you have a simple way to realize that in assembly, so you understand how a compiler works. And you will see that for these statements, for these control structures, more than one way exists to represent them with flowcharts. This here I call variant 1, and the second variant would look like that. And the difference is, in both cases you have a conditional and unconditional jump, but the places are switched. And also in the second variant, the condition is negated. In this first variant, you see the condition in the flowchart as you see it in the C code. What you also see here is a loop. You see that we jump backwards eventually. And that's why we call it a loop. And I want to point it out to show you the difference to an if statement where we only jump forward. So we don't loop, so we don't call it an if loop. And here we also have two variants. Now here it's interesting to see that in this first variant, where we have a condition as we see it in the C code, these places of B and C are switched. You see here in this then branch, I just denoted this block by B. This comes here at the end, and before we have this else block here. And you have to kind of know that if you want to realize it in assembly, or be aware of it, that nothing is wrong if in your assembly code places are switched compared to the description in C code. This happens if you do not negate the condition. If you want to have in assembly the same order of this then block and else block, then you just have to invert the condition.